Happy day, students. Today we are going to work on properties of exponents. 4-3, we're going to call it fun with exponents here and go through a few things for you to know before you get your work. Number one, multiplying powers with the same base. There's a rule when you're multiplying powers with the same base. The rule is you keep the base and add the exponents. Simple as that. So if you're multiplying powers and the base is the same, very important to know that the base has to be the same, you keep the base and add the exponents. The algebraic example would be something like this, which I'm boxing right now. When you have b as a base, raised to a power of m, and you multiply it by the exact same base, b, raised to a power of n, you simply keep your base, as the rules say, and add the two exponents. A number example would be something like 3 to the 5th times 3 to the 3rd equals 3 to the 5th plus 3 to the 3rd, and your final answer would be expressed as 3 to the 8th. I know some of you are going to say, well, how do we express our answer, Mr. Pottinger? Do we express it as 3 to the 5th plus to the 3rd? And the answer is no. You don't need to actually do this step. This is just me showing you what you're doing. The final answer would be 3 to the 8th because you added a 5 and a 3 because your bases were the same. The rationale, or the long explanation for that, would be if you take the number 3 to the 5th and write it in long expanded form, so it would be 3 multiplied by itself 5 times, and then we're going to multiply that by another base of 3 raised to the power of 3. So this right here, the next set, would be 3 times 3 times 3 because it relates to that 3 to the 3rd, where this 3 to the 5th is 3 times 3 times 3 times 3 times 3. When you add those all up, you have 3 to the power of 8, as you see for number 1. Sliding on down to number 2 and 3, we have some examples. Example number 2, we have x to the 5th times x to the 1. Our base is, and by the way, this is x to the 1st. You don't have to express it. Our bases are the same, so all we have to do is add our exponents, and we have x to the 6th, because we have 5 x's in the first base, and we have 1 x in the second base. Next example, x to the 5th times y to the 3rd would simply be x to the 5th, y to the 3rd, because the bases are not the same, so we cannot combine exponents. Next one, number 4, dividing powers with the same base. Rule, keep the base and subtract the exponents. So this time, when we're dividing and the bases are the same, we are going to subtract the exponents. The algebraic example would be b to the m over b to the n. The bases are both the same, so we would keep the base and subtract the numerator from the denominator. Or subtract the denominator from the numerator, in this case b to the power of m minus n. An example, algebraically, would be b to the 5th over b to the 3rd, which equals b to the 5th minus 3, which is b to the 2nd. Again, we can do this because our bases are the exact same. The long explanation would be, for this example, b to the 5th over b to the 3rd. If we wrote the long form of b to the 5th, we would have b times b times b times b times b over top of b to the 3rd, which is b times b times b. Because they're all the same, we can cancel this b with this b, this b with this b, this b with this b, and we are left with b to the power of 2 over 1, and that's obviously expressed as b to the power of 2. Long explanation. Number 5, x to the 10th over x to the 8th. We are left with x to the 2nd because we are subtracting x to the 10th minus x to the 8th, or x to the 10th minus 8, which is x squared. Last rule, raising a power to a power. Rule, keep the base and multiply the exponents. So in the situation algebraically, we have b to the power of m to the power of n. So b to the power of m to the power of n gives us the same base, so we can do our work here. B to the power of m times n. Our example would be 9 to the 4th to the power of 5. We're multiplying, as the rule says, or we're raising a power to a power, so we multiply the exponents. In this case, we have 9 to the 4th times 5 is 9 to the 20th. The long drawn out example of this would be the fact that we have 9 to the 4th 9 times 9 times 9 times 9. And we are doing 9 times 9 times 9 times 9 5 times. So we have this as 1. This would be our second. I'm going to go really fast here. Our second 9 to the 4th that we have to do 5 times. Our third 9 to the 4th. Our fourth 9 to the 4th. And our fifth 9 to the 4th. And if we add all the 9s we're multiplying together, we got 4, 8, 12, 16, 20. Keep the base, we got 9 to the 20th power. Whew. 6 to the 7th raised to the power of 9. We would end up with 6 multiplied by itself 63 times, because 7 times 9 is 63. 17 to the power of 2 raised to the power of 20 would be 17 to the power of 2 times the power, I'm sorry, it's a negative 20. So again, the problem is 17 to the power of 2 raised to the negative 20th power. The base is 17. Take your first exponent, which is inside the parentheses, and multiply it by your second exponent, which is raising the power of the original, and we get 17 to the negative 40th power. The last one, a little bit trickier. We have 2 to the third to the power of 12 to the negative third power. So our 12 multiplied by negative 3, we have 2 thirds to the 12 to the negative third, which would be 2 thirds to the negative 36th power, because 12 times 3 is negative 36. Good luck.